Good morning. Still morning, I guess. Late morning. My name is Teresa Chow. I'm the HPLC group leader at WMRC. I would also like to welcome you here too. Very happy we have this symposium. Today I'm going to talk about the evaluation of analytical method for pharmaceuticals and personal care products. And this is a very hot topic for the last 7 years or so since the report from USGS. But I've been interested in this for a long time, but until recently, that about a year ago, that we had bought the HPLC tandem mass spectrometry that can make it possible for us to look at the analytical side of it, because it really need a very high technology instrument to do this kind of low level. As you hear, that most people are talking about PPT level, So for regular HPLC with UV detection or anything, that you cannot go down to that level. Just some background on the pharmaceutical and personal care, for short PPCPs, that mainly come from the prescription and over-counter drugs, a lot of antibiotics, hormones, estrogen type of compound, like from birth control pills, veterinary drug use, a lot from using on the livestock animals, pets, and also seafood industry. They use a lot of antibiotic for raising seafood. I kind of stopped eating shrimp because I found out that the shrimp nowadays has so much antibiotic. And antibacterial soap and antibacterial microbial soap that we use daily pretty now, and from lesser extent from cosmetic and vitamin type of things. The sources of this, of course, mainly is come from the human activity, from when we take the drug and then the excretion and usually the compound, the parent compound, and also some metabolite through excretion to the wastewater treatment plant. And also, don't forget that a lot of people flush the unused medication down the toilet, and used to, they tell people to do this. This is really not the right way to do. And also the disposal, just kind of disposal into the garbage. And residue from hospital and nursing home, I presume most of the antibiotic type of compound. Veterinary drug use, mainly the antibiotics and steroid that they administer to animals. Like I said, the seafood is another big area that I heard about, that the U.S. refused to import the shrimp from Thailand because they found there's so much high level of antibiotic in the shrimp they use over there. And livestock waste from all the cow, horses, and all these wastes that they can go into wash to the groundwater and cause the PPCP in the surface water. The residue from pharmaceutical manufacturing, that I think this area is pretty well defined and controlled, so that is not the biggest concern. As we hear about, starting in late 19 to 2000 year, the USGS did a very national big survey. They surveyed 139 streams across 30 states, which include Northeast Chicago. You hear about that. And they find that 80% of the water sample contained the residues of PPCP. Of course, we're talking about very low ppb or PPT level, parts per trillion level. And then until recently, we hear a lot of talks about what's the problem. We find intersex fish in the Potomac River. They found that the male carry eggs in the testes. And then the research at the Great Lake Water Institute that in Milwaukee, they showed that the lipitor, or so-called, they can cause the fish to deposit fat into the eggs, which is it going to affect the reproduction? Who knows? Although we may not see the fish with so many hands yet, but definitely it's going to affect our water system and probably small amount to our human health. What are the research needs for this area now? Of course, I come up with 3 areas just kind of to talk about. The monitoring survey in Illinois, that's why we had this symposium. We want to find out what kind of work have done in our own state. We had the Northeast Chicago area data from the USGS report, and also IEPA now just kind of start doing monitoring some data, try to get some data in Chicago area. And we also had the Central Illinois data from Mike Coy's data that we just heard about. So I think that there's definitely more need for monitoring. Maybe in the Southern Illinois area that there's more agricultural and farm use that we should also monitor the stream over there. For the analytical method, we definitely need more laboratory that they can analyze these types of compounds at the sub-PPB level, PPT level. Right now, there's not so many laboratory can do this nationwide, and the laboratory they can provide these kind of services. They charge close to $1,000 per sample, and also according to the chief of EPA environmental science section, Christian Dalton, he's also recommend that we really need a lot more standardized method for data comparison, because now a lot of data being published paper, but there's kind of like cat and dog. Sometimes you cannot compare them. They are really different. There's a lot of issue in the quantitation method, whether you're using internal standard, external standard, just kind of single ion monitoring, and lately the biggest thing they come up is the isotope dilution method for more accuracy. So it's really hard to compare the data. And then another area would be the pond source study. We don't really have a lot of data in that. We know that in the wastewater treatment plants, sometimes most of the time they only sample water at the influent and the effluent and kind of compare the data. But where do they come from in the urban environment? Do they come from mainly hospital and nursing home for antibiotics, so if we kind of have some more of this kind of data, maybe we can do some kind of pre-treatment before they get into the wastewater treatment plant. So there's definitely some need for this kind of data. And based on the Mike Coy's report, that since it's kind of near us, near the Central Illinois area, I kind of used his report and come up with a list of target lists. The one that I show here, about 18 of them, just kind of represent analgesic, anti-inflammatory, painkiller type of thing. So that's the acetaminophen, ibuprofen, naproxen type of compound. And also caffeine. Everybody drink coffee. We always find caffeine in the water. We know that. And antibiotics, so from ciprofloxacin to trimethoprim, all these are different kinds of antibiotic. I kind of like to have kind of a couple from each family. And antimicrobial, we know that with triclocarban and triclosan is being used in our kind of daily life nowadays, and they are also found very commonly in the water. And anti-lipid epileptic is carbamazepine. That is also being found quite frequently in the water. And antacid, cimetidine, and ranitidine. I also add another compound is the anti-lipidemic is the gemfibrozil. Just kind of add to that. Because a lot of people are taking medication for the high cholesterol. The method that we start evaluating is based on the brand new US EPA method 1694. It's just being published by US EPA, come out in December 2007. Basically, they have 4 methods for the groups of the target analyzed using positive and negative ion modes. My goal is to try to optimize it to use a little bit less method for the list that I had, about 20 of them. I use a HPLC water symmetry column. Most the US EPA method use a C18 column. I kind of went to a CA. I like to have them come out faster, so I use a CA column. We're using the 2 milliliter ID, using a flow rate of 0.2 ml per minute. And the mass spec that we had is the water micromass quattro micro tandem mass spectrometry. We're really happy to get that because then now we can do the MS work. Now the data I'm going to present to you is really the last 2 weeks that we start really working on it. Me and my chemist Monty Wilcoxon, so the data you see is just about 2 weeks work. We studied the solvent in fact on the elution of response. The USGS method, they're using a mixture of methanol and acetonitrile. We know that most of these chemicals, they are soluble in a mixture. They are sometimes they're more soluble in methanol, sometimes they're more better in acetonitrile. So we kind of take a look at it, and we find that acetonitrile is probably not the best solvent to use because the peak tend to be kind of broader, and methanol, on the other hand, is kind of give the best response, and we had the biggest, the highest peak height, but the peak always kind of tend to be more broader. And so the mixture between the methanol and acetonitrile seems to give the nicest, the intermediate, good response, but also the peak is sharper. And so this on one of the triclocarban and also another antibiotic. So we decided to use the mixture of methanol and acetonitrile, just like US EPA. And another thing, we also look at the dissolution gas effect. We're using nitrogen on the instrument to kind of remove the solvent, and they call the dissolution gas, and it's kind of nebulize the flow and then remove the solvent, the less volatile solvent. And as you can see that we're using from 250 to 750, and you see that the higher the flow rate, the better the response. The reason we did this kind of study is because one of the sample, triclosan, in the published paper, they said that the best flow rate they use is 250. And so we did look at that. 250 does seem to give a little bit better response, but then for all the other PPCP analyte, we found that 750 is better. So we will have to use 750, This is the method one, basically using a formic acid and ammonium formate buffer with a mixture of 50-50 acetonitrile methanol. As you can see that we can look at 11 compounds using this method. This has a mixture of positive ion and negative ion. Our instrument, you can monitor the analytes in both positive and negative ion mode, which is a really nice feature that we don't have to run and you can monitor both. And these are all the positive ion, and we also developed the we call the MRM method, that from the parent ion to a daughter ion. So we monitor the daughter to the parent to the daughter, and that will give you the highest sensitivity. And this is a 20 ppb level, which is very good. I think we can go down, definitely can go down to 2 ppb, it seems to me. And then with the additional 1,000-fold of concentration from SPE, solid phase extraction, we can go to, part per, 1 or 2 parts per trillion level. Yeah. And this is the other analyte that triclosan and triclocarban. Now with this method, we have the tetracycline. You have here about the family tetracycline. It's a family of antibiotic. It actually has many because of the metabolite. So it has probably 6 or 7 related compounds. We had the tetracycline and the oxytetracycline by this method, but we had no response from it. So and the literature say that actually tetracycline, as Patrick says, sticky antibiotic, is tend to stick to the silanol groups, like glass and the column inside the backbone of the column is silanol. So they tend to stick to the column, and I think that's why we don't really have good response. And the US EPA method actually has a method too. They're using, instead of formic acid, they're using an oxalic acid. So we tried that. It does really show that with the first two is the formic acid, there's no response. And then when we go to the oxalic acid, we had nice response for the analyte. I'm still working on it. My rationale when I first think about it is I said, well, maybe I add the oxalic acid to the formic acid buffer, and then maybe it will give me the response for the tetracycline. But we already tried that. It doesn't seem to work with the other pharmaceuticals. And it seems to give a much lower response for the other one by adding the oxalic acid. The interesting thing is I also found that oxalic acid is kind of not very volatile. It's a ligand. So maybe that's why it helped the tetracycline come out. But it's not volatile, and using the electrode spray, you really need volatile compound. So if it is not volatile, actually it will eventually cause problem in the mass spec, in the MS region. So I had to take more further look at it. And then the method 3, and then another thing for a lot of these painkillers type ibuprofen, naproxen, and they don't give a good response either with the formic acid, the first method. And so, because when you look at the structure, they are really kind of like they had carboxylic acid on the, so it's a organic acid, and they tend to, and this is the negative ion mode. So I think with the formic acid, that with the low pH, they protonate the compound. So, but for the negative ion, you want to remove the proton, so it does not make a good ion response for it. That's why we had to switch to a water instead of formic acid. We just use water, and that give a higher pH, and that will give a very nice negative ion. So for all these compounds, the gemfibrozil, this is the lower cholesterol drug, and naproxen, ibuprofen, they do really well with just the water instead of formic acid. And we can also add the trichocarbamate and the triclosan into this method. And so, in a way, if we had to use all these 3 methods, then we just kind of run all the negative ion by this method. And the first method just run the positive ion. So that will also give more sensitivity too. So this, I think that's it. This is so far we have done so far for the 2 weeks. The next thing we have to do, we will try to do the solid phase extraction to find out efficient recovery efficiency. As I did mention earlier, is like I said, the quantitation is a big problem for MS, for LCMS, whether you're using internal standard or the isotope dilution method, it makes a lot of differences in the quantitation. The isotope dilution seems to be the best method nowadays. All the paper come up using this technique. But the problem is, you all know that it's very expensive. One isotope compound will cost at least $400. So when you're talking about 20, then you're talking about $8,000. So this is a big problem. So that's why most, like even the US EPA method is just using internal standard. So that is a challenge we have to overcome in order to analyze this compound at very trace level. Any question?